Okay, think about this for a second. The bridges you drive over every day, the buildings you work in, what if they could actually tell us they were sick? Long before you could ever see a crack or a problem? Well, today, we're diving into exactly that, how we're literally teaching our infrastructure to talk.
It sounds a bit like science fiction, doesn't it? I mean, how can a giant structure of concrete and steel communicate its health? That is the exact question we're answering today. And the solution? Well, it's pretty incredible. We give our infrastructure a nervous system and a very, very smart brain.
For decades, our approach has been totally reactive. We wait for a problem we can see, we send out inspectors, and we fix things after they've already gone wrong. But that whole mindset is shifting. The new way is completely proactive. We're learning to listen to a structure's heartbeat 24/7, monitor it automatically, and actually predict problems before they ever become dangerous.
Now, to understand why this shift is so unbelievably critical, we need to look at the problem. We're facing what you could call a silent crisis. Our infrastructure is getting old. And just like any patient, age brings a ton of hidden issues that you just can't see on the surface.
And these threats are everywhere. We're talking about material fatigue from the constant stress of traffic, corrosion that's literally eating away at steel from the inside out, microscopic cracks that can spread like a disease through concrete. There's even something called scour, where floodwaters can just erode away a bridge's foundation. These are the kinds of invisible dangers that build up for years, completely unseen by the naked eye.
So how in the world do you fight an enemy you can't see? Well, you give the structure a voice, and that voice comes from a technology called Structural Health Monitoring, or SHM for short.
SHM is pretty much what it sounds like. The best way to think about it is like a nervous system for a bridge or a building. It's a whole network of high-tech sensors that are constantly feeling, measuring, and seeing, which allows the structure to communicate its internal state in real time.
And this nervous system has an incredible array of senses. You've got accelerometers that feel the tiniest vibrations, strain gauges that measure stress on the materials, fiber optic cables can detect microscopic bends, LiDAR and high-risk cameras can spot cracks that we could never see. There are even sensors that can smell the chemical signs of corrosion. Heck, we can even use satellites to track ground movement down to the millimeter.
Okay, so our bridge now has a voice and a nervous system sending out constant signals. But this creates a whole new challenge, right? Who is listening to all this chatter? This is where we give the structure a brain, an AI supersense that's capable of making sense of it all.
And when I say chatter, I mean it. The scale of this data is just staggering. A single structure with hundreds of sensors can generate terabytes of information every single day. That is way more data than any team of humans could ever hope to analyze in a meaningful way.
But here's the real kicker. The vast majority of this data, we're talking over 99.9% of it, is just noise. It's the bridge just being a bridge, behaving normally. The AI's real challenge is finding that tiny fraction of a percent, that one little signal that's out of place, that indicates a problem is developing. It's the ultimate needle in a haystack.
So here's how it works. First, the AI just vacuums up all that sensor data. Then, using machine learning, it gets to know the structure's unique heartbeat, how it vibrates in the wind or expands in the hot sun. Once it knows what's normal, it can instantly detect any deviation from that pattern. And this is the crucial part. It sends a predictive alert, giving engineers time to act before a problem becomes a catastrophe.
And this AI is way more than just a simple alarm. It's performing some really specific, sophisticated tasks. It can classify the type of damage. Is that a crack or is it corrosion? It runs predictive analytics to forecast the remaining useful life of a component, literally telling us a specific cable has, say, 5 years left. It can even fill in data gaps if a sensor goes offline, which means the monitoring never stops.
Now, let's take this one giant step further. All of this incredible real-time data can be used to create something called a digital twin. And this isn't just a static 3D model. Oh no, it is a living, breathing, virtual replica of the real structure. And it's being updated constantly with data from its physical counterpart.
This digital twin becomes the ultimate virtual sandbox. Engineers can literally simulate a massive earthquake to see how the virtual bridge holds up. They can test what would happen if you doubled the traffic volume. They can model all these incredibly complex scenarios and optimize maintenance schedules with amazing precision, all without any real-world risk. It's a total game changer.
So what does this all mean when you put it together? This combination of a nervous system and an AI brain isn't just a small upgrade, It is a complete reimagining of our infrastructure. It fundamentally changes everything.
So why does all this matter to you and me? Well, it means a level of safety we've never had before, because we're shifting from reactive fixes to proactive prevention. It means huge cost savings by targeting maintenance exactly where and when it's needed. No more guesswork. It means our vital infrastructure lasts longer. We can build new things that are far more resilient to climate change. And ultimately, we can create smarter, more responsive cities.
You know, this technology is moving us toward a future that really was once just a dream. So I'm going to leave you with this thought. What if our cities became truly alive? What if that entire network of roads, bridges, tunnels, and buildings could all communicate as one intelligent organism, telling us exactly what it needs long before we even know to ask? That's the future we're building right now.